This question is simple. I mean, solution is also simple. You have a function defined on 1 comma infinity. It is a differentiable function. F of 1 is 1/3. And they have given you this equation which it follows for x belongs to the same interval, the domain you have. Then they are asking what is value of f of e. So basically you need to find your function. Once you know your function, you can always find out what is the function value at e. E is the base of the natural log. So what do we do? Of course, right? This is under integral sign. So you have to differentiate this equation. What do you get? Can you tell me if you differentiate that equation? You have 3 and derivative of this whole thing would be just f of x. Okay, that is the Leibniz rule which says that it is just f of x. And here you can use the product rule. First function derivative of second plus second function into derivative of first, and the derivative of x cube is 3x square upon 3. So this is what you get. Now basically can you see you are forming a differential equation now? Instead of f prime, if I write dy by dx, and instead of f if I write a y, then I end up in getting minus 2y is equal to x square. This is the differential equation which I get. Now you can clearly see that I can make it a linear differential equation. How does a linear differential equation looks like? I have divided by x because I know my x is in this interval and x is not 0. My linear differential equation looks like. And how do you solve it? By finding out what is the integrating factor. That is e to the power integral p dx. That is what you want to find out. And final solution you write is y times the integrating factor is equal to integral qx times the integrating factor dx plus c. That's your solution. So let's get to work with this differential equation which we have in hand. So first try to find out what's the integrating factor. E to the power integral, instead of p what do I have? Minus 2 over x dx. And this is minus 2 log x. I don't write a modulus because I know my x is always positive. X belongs to the interval 1 comma infinity. It is always positive. So what do I end up in getting? Log 1 over x square, and this is 1 over x square. That's my integrating factor. Now let's write the solution now. Y times the integrating factor is equal to integral of qx. This is my qx, right? So x times the integrating factor dx plus c. So x square plus what is this? 1 over x. So this is equal to log, again I am not writing modulus of x but just x plus c. How do I get my c? Initial condition given to us is f of 1 is 1/3. So just plug in there. So y is 1/3 when x is 1. So log 1 is, it's 0. So c value you got to be 1/3. What are they asking? What is the y value at e? Function value at e. That's what they want. So you just keep your y. Instead of x, you want to write a e. Log of e, that's 1. Okay, so this is what you get. So finally, what's your y value? E square times, this is 4 by 3. Right? So that's your solution. Okay. Function value at e is the c. Okay, 4e square over 3.